So good morning student. Welcome to ABA Online Physics, our YouTube channel. Here the basic physics for NEET and JEE student by Sumit Mashakitri sir, MSc Physics Gold Medalist, B.Ed. In this lecture we discussing about some basic phenomena about the physics. So first physical word. Here we discussing some content, what is science, then step involving in scientific method, what is physics, then scope and experiment of physics, physics and technology and society, fundamental forces in nature, nature of physical laws. The word science is originated from Latin word that is scienta. Its meaning to know. Okay. The science is originated from the Latin word scienta, meaning to know. The knowledge which man has gained through the observation and experiment, when organized systematically, is called as a science. Then, what is meant by physics or physical science? The science which deals with the non-living things are called as a physical science. The examples of physical science are physics, chemistry, geology, geography, astronomy, astrology, oceanology, etc. These are the physical sciences. Now, the word physics comes from the Greek word that is physis. Its meaning nature, and introduced the first scientist, that is Aristotle. The man always been fascinated by nature, so he questions and answer for every phenomena. The branch of science which deals with the study of nature and natural phenomena is called as the physics. It is accepted that all the events in nature takes place according to some basic laws. Physics reveals these laws from day to day observations. I given some examples here. Now, the step involving in scientific method. The first step is ask the questions, do the background research, then construct the hypothesis, then test with experiment and analyze the result and conclusion. If the hypothesis is true, then report and result. Report the result. If hypothesis is false or partially true, okay, then think, try again, construct the hypothesis, test with experiment, analyze the result, draw a conclusion, and again report the result. These are the steps involving in scientific method. Now, the knowledge of physics accumulated till 19th century is called as the physics, classical physics, that deals with microscopic phenomena. It includes subject like mechanics, thermodynamics, electromagnetism, and optics. These are the classical physics. And recent knowledge beyond the 19th century termed as the modern physics, consisting of two theories. The first one is relativity and another one is quantum mechanics. Then the scope and excitement of physics. The scope of physics is very large. Physics deals with wide variety of disciplinary such as mechanics, heat and light. First, the study of mechanics helps to know the forces involving flight of bird, walk of man and so on. Then second one, the study of heat helps to know rise and fall of temperature, working of heat engine and so on. Then third one, the electricity helps to understand the basic principle involving generators, motors, etc. Now, the exciting disciplinary of modern physics takes into account a microscopic world of atom and electron. The distribution of charges proposed by Thomson, J.J. Thomson, His model was tested by Infant Rutherford in 1909 by using the subatomic projectiles bombarded a target of atom. These projectiles, called as the alpha particle, were identified one of the product of radioactivity. Then next, physics in relation to the science, society and technology. Among the disciplines of science, the only discipline which can be regarded the most fundamental is physics. It has played a key role in the development of all other disciplinary. For example, physics in relation to the chemistry. The study of structure of atom, radioactivity, X-ray, diffraction, etc. in physics has enabled chemists to rearrange the element in the periodic table and to have a better understanding of chemical bonding and complex chemical structure. This is the physics in relation to the chemistry. Now second one, physics in relation to the biological science. The optical microscope developed in physics are extensively used in the study of biological samples. Electron microscope, X-ray and radioisotopes are used widely in medical sciences. Then physics in relation with astronomy. The Grand Astronomical Telescope and Radio Telescope has enabled the astronomers to observe the planet and other heavenly objects. Then next one, the physics related to the mathematics. Mathematics has served as a powerful tool in development of modern theoretical physics because without mathematics we cannot study the physics. It is the important. Then next one, the physics related to the other science. The other science like biophysics, geology, hydrology, oceanography, seismology use some laws of physics. Then physics related to society and technology. The development of telephone, telegram and telex unable to transmit the message instantly. The development of radio and television satellite has revolutionized the means of communication. Advance in electronics, that is computer, calculator and laser, have greatly enriched the society. Rapid means transport are important for society. The generation of power of nuclear reactors based on the phenomena of controlling nuclear chain, digital electronics is widely used in the modern technology development. Now, the basic forces in nature. The first force is gravitational force. It is the force of attraction between the any two bodies in the universe. The gravitational force is inversely proportional to square of the distance between two bodies and directly proportional to product of their masses of two bodies. The gravitational force is small when light bodies is considered and is considerably when small mass. Therefore, F is equals to G m1 m2 by r square. Here G is called as the gravitational constant, m1 is the mass of particle 1, m2 is the mass of particle 2 and r is the distance between the two body masses. Now the electrostatic force. It is the force between the two charge is stronger than gravitational force. It also follow inverse square law and it is proportional to product of charges. Means F is equals to K q1 q2 by r square. This is the electrostatic force. Now the magnetic force. It can be either attractive or repulsive. It can be force between the two magnets or force on a magnet placed in a magnetic field. The next one, that is electromagnetic force. An electric charge moving in a magnetic field experience a force that is called as the electromagnetic force. It is the combination of electricity and magnetism. Then nuclear force. This is the strong nuclear force with a short range. It is non-central, that is, it does not direct along the line joining the center of interacting particle. These forces acts within the nucleus. Now weak force. This kind of interaction is not well understood yet. Its range shorter the nuclear force. It is important only certain nuclear process like radioactive beta decay, strong electromagnetic weak, means it like 10 raised to power 2 raised to 1 is to 10 raised to power minus 12 is to 10 raised to power minus 36. Comparison of electrostatics and gravitational forces. So here is some point of symmetry and point of this similarity. Point of symmetry means they are central forces, they obey the inverse square law, they obey the conservative forces, they operate even in vacuum. And point of this similarity, gravitational force are attractive while electrostatic force may be attractive or repulsive. Then gravitational constant proportionality does not depends on the medium while electrical constant depends on a medium. The electrostatic force are extremely large as compared to gravitational forces. Now the law of conservation. There are nearly 14 laws of conservation based on the symmetry principle in physics. Anything that happens must not be forbidden by the conservation law. Some of the important ones, the law of conservation of linear momentum. If the external force act on the system of colliding object, then total momentum before collision is equal to total momentum after collision in the same direction. That is the law of conservation of linear momentum. The law of conservation of energy. Energy cannot be created nor be destroyed. They can only be transformed from one form to another. That is the law of conservation of energy. Now third one, law of conservation of angular momentum. If external torque acts upon the system, then the angular momentum of the system is remains constant. That is the law of conservation of angular momentum. Now the conservation of charge. The total electric charge of an isolated system remains constant. That is the conservation of charge. Okay, we will stop here. In next lecture, we will discuss about the syllabus of NEET and JEE exam.